we have one more kind of graph that we need to cover, and we're going to do that with a MyOpenMath problem to kind of illustrate what's going on here. So this is called a histogram. It's similar to a bar chart, but a little bit different. So let's highlight some of the differences. I've got one right here, copy of it, so we can kind of draw on it and illustrate what's going on here. Okay, so the biggest difference between a bar chart and a histogram is what's going on here on the x-axis. Okay, for a bar chart, the bars are given a category label, right? They could be labeled like A, B, C, D, whatever. Okay, here we're not labeling the bars. Instead, each bar is represented by a range of values. So this bar is represented by the range of values between 0 and 1,000. This bar here is represented by the values between 1,000 and 2,000. This bar here are the values between 2,000 and 3,000. Okay? So we use histograms especially when the data we're dealing with is quantitative continuous data. So we're dealing with ranges of values instead of just a few specific values. Okay? Notice also that unlike a bar chart, there's no gap between the bars. When we were dealing with bar charts, there were these gaps between each bar. When we deal with a histogram, it's all kind of shoved together to really emphasize the fact that we're dealing with continuous data, and there's not a big difference between 999 and 1001. And so we put the bars right next to each other to give this impression that the data's that we have this continuum of data. Okay? All right. So let's take a look at this particular problem and see what's happening here. Okay? So a survey was conducted to determine the distribution of home sizes in the state of Montana. The data obtained was organized into the following histogram. So that's the histogram that we've been talking about. Okay? The histogram has home square footage and then the frequency of each range. So for this first range, 0 to 1,000, there are 60 homes in that range. Okay? About how many homes surveyed were smaller than 3,000 square feet? Okay, so notice the about here. Why would that be? Well, notice in a histogram there is naturally a little bit of ambiguity. 3,000's right here, but if your home is exactly 3,000 feet, would you be in the bar on the right or would you be in the bar on the left? It's not especially clear. There's a little bit of ambiguity. So that's why we have about. That's why we're dealing with about. We want to know about how many homes surveyed were smaller than 3,000 square feet, because we usually don't know, unless we know beforehand how the histogram was constructed, we usually don't know which bar exactly 3,000 would be in. And we're only interested in values smaller than 3,000 square feet. Okay? Okay. So with that out of the way, with that disclaimer out of the way, let's actually find which bars we're interested in. So we want to know how many homes surveyed were smaller than 3,000 square feet. So 3,000 was right here. We want values smaller than 3,000. So we want everything to the left of this number. Okay, so that means this bar, and this bar. Okay, any homes in those bars are going to be about the homes smaller than 3,000 square feet. Okay, and we could see from the picture or from the graph that this first, well, let's start with this bar. This bar, there's 60 homes between 0 and 1,000. If we look at this bar, the second bar, okay, between 1,000 and 2,000, there's 100 homes. And if we look at the third bar between 2,000 and 3,000, there's 120 homes. Okay, so if we put those together, we'll have about how many homes are smaller than 3,000 square feet. So let's just add those numbers together. We can use the calculator at the top to do that for us. It's not that hard to do. The numbers are pretty easy to work with, but if you want to save yourself a little mental work, you can let the calculator do it for you. 60 plus 100 plus 120 is 280. So that's about how many homes surveyed were smaller than 3,000 square feet. Okay? All right. About what percentage of the homes surveyed were larger than 6,000 square feet? So we're going to use this again. So I'm going to get a fresh page here with a new graph so we could use it. Now we want about how many homes surveyed are larger than 6,000 square feet. So it's the same issue as before. We have 6,000 here. Now we want the homes that are bigger than it. We don't know if 6,000 is counted in this bar or this bar, which is where the about comes in. Okay. But it shouldn't matter that much. We have a lot of homes. There are probably not many homes exactly 6,000 square feet, right? 6,001 would be counted over here. 5,999 would be counted over here. Where 6,000 is counted is probably not that big a deal. Okay? Now we're interested in the homes that are larger than 6,000 square feet. So here's 6,000, we want larger. So we want this bar and this bar. So those are the bars we're counting. They look to be the same height, and if we look over here, they're right in between 0 and 20. Okay? So it looks to be about 10. So that's what we're going to use. So both of these bars are 10. Okay? So the total homes larger than 6,000 square feet. The total is 20, the 10 plus the 10, okay? But that's not what it's asking. It's not asking the total. It's asking the percentage. So how do we find a percentage? Well, we need to find the fraction or ratio or proportion and then multiply by 100, right? Move that decimal point over. So we found the part that we're interested in. Now we need to find the whole. So we want part over whole to find that fraction. The part that we're interested in, there are 20 homes in that part. To find the whole, we need to add up the total in all the bars. Okay? So if we look at all the bars, there's 60 in this bar, 100 in this bar, 120 in this bar, 80 in this bar, 60 in this bar, 40 in this bar, and then I've already identified how many in these two bars over here. Okay? So I'm going to add up all of that to find the whole, or the total number of homes in the survey. Okay? So let's add all those together. 60 plus 100 plus 120 plus 80 plus 60 plus 40 plus 10 plus 10. Click evaluate, and so it just evaluates that last line for me. It's 480. So the total number of homes is 480. So that's the fraction or proportion of homes that are larger than 6,000 square feet. If I convert that to a decimal, 20 divided by 480, do the division, I get 0.04166667. 0.04166667. And so to convert to a decimal, what I do is I move this decimal 2 places to the right. Okay, so I get 4.166667%. Okay, if I want to do that using the calculator, I just multiply by 100. Moving the decimal 2 places to the right is the same as multiplying by 100. See, 4.166667. Now, you want to be careful with rounding when writing your answer in here. Your best option is don't round at all, okay? So I'm going to take this number, and I'm just going to take the full thing, because we don't want to deal with rounding error. The worst thing is when you get the answer right, and then you round it too aggressively, and then you got it right, but it says it's wrong, and you can't figure out why. So the best way to handle that is don't round at all. I like to copy and paste the answer directly from the calculator into the answer box. That way I don't have to worry about rounding. I don't have to worry about typing the number in wrong. It's exactly what the calculator says, so I know that if there's a problem, it's with the calculation and not with how I'm writing the answer. Okay? So let's submit. And we have the correct answer. So 280 homes were smaller than 3,000 square feet, and about 4.16667% of them were larger than 6,000 square feet.